resistors in series and resistors in parallel. These are the two topics that are coming in the quiz that we're gonna have on Friday. Okay, we have this example over there. Okay, we have this example, and I say for the circuit that you see, you need to find the equivalent resistance, the equivalent circuit. You need to sketch it. You need to find the current in the circuit and the potential difference in each resistor. Okay, that's going to be the instruction in that exercise. Now, how do you recognize, how can you tell the difference between resistors that are working in series and resistors in parallel? Well, guys, the main difference is how the resistors are located. Take a look to this sketch. In this, you have the battery located right there. Okay, so in here, the current is going to travel from this point until the end. Okay, and as you can see, the current is only in one path. I mean, the current here is not divided in different paths, it's just in one path. It comes in the wire, passes through the resistor, continues in the same wire, passes from the resistor, continue in the wire, resistor, wire. Okay, but you can see, even though it passes through the resistor, the direction of the current is not changing. That's how you recognize a resistor in series. Another way to do it is to work in the first step. For resistors in series, the first step is going to be, you need to open the circuit. Okay? You need to open the circuit. And how do you open it? You're going to start with the battery. Okay? Or with the outlet. Anyway, with the potential difference, you're going to start. So in the sketch, you will do this to represent the battery. You know, it's 9 volts. And then you start completing the sketch. Okay? After the battery, you have wire. Okay? So you draw the wire. Okay? After the wire, you have a resistor of 4 ohms. So you put it over there and you indicate that this is 4 ohms. After the resistor, you have wire. So you continue. Wire, okay? Then you have resistor of 2 ohms, wire, and resistor of 2 ohms. So resistor of 2 ohms, wire, and another resistor of 2 ohms right here. Okay, like that. After that resistor, you have wire and a 5 ohm resistor. And after the 5 ohm resistor, you have wire, the resistor of 3 ohms, wire, and the end. Okay, so wire, resistor of 3 ohms, wire, and the end. That is how you open the circuit. Now, with this, you're able to notice that you have resistor 1, resistor 2, resistor 3, resistor 4, and resistor 5. Sorry. Resistor 5. The main idea of this topic is not to sketch, but it's a very important step. When you do a sketch, it gives you the idea of how those resistors are working, because from that it will depend the formula that you will choose. Remember that we have two different formulas to calculate the equivalent resistance. Now, when you have all the resistors in this already open, you see that they are next to each other. They are on the same line. They are not face to face, because apparently if you take a look, remember that I gave you the main idea on this. Wait. So you have your circuit, okay? And I told you, last class, I told you, if the resistors are face to face, they are working in parallel. But take a look. These two resistors are face to face, okay? But they're not working in parallel, because now that you see the circuit, now that it's open, you see that they are not face to face. They are in front. I mean, they're in the same line, sorry. So when this happens, when you open the circuit, it tells you, it gives you a better idea how the circuit is really working. That's why here I totally recommend to do a sketch to open the circuit. Now, all the resistors are in a single line, so we say, okay, this circuit is working in series. Okay, it's working in series, and from this you can start getting what the problem is asking you to find. First, it's asking you to find the equivalent resistance, and that's what we're going to do now. Okay, we're going to find reg. According to the formula, reg is equal to the addition in series, okay, is equal to the addition of the individual resistances. So you're going to have resistor 1 plus resistor 2 plus resistor 3 plus resistor 4 plus resistor 5. Okay? So reg will be equal to 4 ohms plus 2 ohms plus 2 ohms plus 5 ohms plus 3 ohms. Reg is equal to how much? 2 and 4, 4 and 2 is 6, 8 and 5 is 13, plus 3 is going to give us 16 ohms in total. So with this, you answer the first part of the problem. Find the equivalent resistance. Check. Now we need to go to the step number 2, which is calculate the equivalent circuit. Not to calculate. Make a sketch of the equivalent circuit. Now to do that, pretty simple. The equivalent circuit is very, very simple. Okay? This equivalent circuit is going to have the battery or outlet, okay? And a wire that is going to be connected to the equivalent resistor. So the sketch is pretty simple, but you need to include the information that you know so far. You know that the battery is 9 volts, and you know that the equivalent resistance is 16 ohms. So you're going to include that information here. Now, another thing that is good that you include is how the current travels in this circuit. Okay? With this, you already do the step number 2. You already have the equivalent circuit. Now, we need to find the current in the circuit. Okay, that is part 3. Current in the circuit. So, we move on to the to step number 3. And you say current in a circuit. Now, to do this, take a look. I already wrote here. You're going to be making use of the Ohm's law, already isolated for the current. Okay? So, according to the Ohm's law, current is equal to potential difference divided by the equivalent resistance. All you do after is you plug in the givens. So you say current equals to potential difference, which is 9 volts, and the equivalent resistance, that is 16 ohms. How much is this?
0.56.
0.56. Okay, so we say current equals 0.56. These are amperes. Okay, with this we finish the part number 3, which is to calculate the current in the circuit. So because we already finished, we check. Now the last part, we haven't done it yet, is to calculate potential difference in each resistor. Before I go into that, I want to tell you about this big box right here. Okay? It says current is the same in resistors in series. That is a rule. Okay, that's why it is in brackets. Okay, that is the rule. The current in all those resistors is going to be the same. That means that the current here, let's go to the sketch. The current here, which is 0.56 amperes, is going to travel through the circuit. It's going to pass through the resistor, and it's going to be the same current. I mean, it's not been divided in different paths. It is the same path. So the current is going to be the exact same in all resistors. That is a rule. In other words, the current, because it only has one path, the current will remain constant along the path. Okay, it remains constant because it has only one single path. So the current is not going to be divided. So, how do we do in that part? Well, we're going to base on this principle to calculate the potential difference. Now take a look. Okay, take a look. We need to calculate the the potential difference in each resistor. What I do know about the potential difference is that is 9 volts. Okay, this is the potential difference of the total circuit. Okay, potential difference in the total circuit. Now, this potential difference is going to be different according to the resistor. Okay, I have this resistor is going to have a different potential difference. The number 2 is going to have another potential difference, and so on. That means that we need to calculate each potential difference. To do that, we're going to apply the same formula, the same law, Ohm's law, but now isolated for potential difference. Take a look. Because we have 5 resistors, we're going to find 5 different potential differences. So take a look. The potential difference 1. Okay, so the Ohm's law is this one. Current equals delta V divided by R. Okay, this is the main equation. If I isolate for delta V, that means that the resistance that is divided gonna go to the other side to multiply. So I times R equals delta V, and this is the equation that we're gonna be using. Take a look. Delta V then is going to be equal to the current times the resistor. If I'm talking about the first resistor, it's going to be resistor 1. The potential difference in the second resistor is going to be the current times the resistor 2. The potential difference in the third resistor is equal to the same current times the resistor 3, and so on. Delta V4 then is equal to current times resistor 4, and delta V5 equals to current times resistor 5. Those are going to be all calculations that we need to do. Now, all we do, we plug in the givens. So we say delta V1 equals to current. Current is the same. Remember this principle, okay? Remember this rule. Current is the same in all resistors in series. So all currents are going to be the same, which is 0.56 amperes times resistor 1. Let's take a look. The resistor 1, take a look, is 4 ohms. Potential difference 2 is equal to the current, same current, but resistor 2. As you can see, is 2 ohms. I follow the same idea in the rest of the formulas. So we say potential difference 3 is equal to the current times resistor 3, that is again 2 ohms. I apply the formula in the next equation. And I say potential difference 4 is equal to the current, which is the same, and resistor 4, that is 5 ohms, times resistor 5, that is 3 ohms. Okay, you apply the formula in all of them. Now all you do is you solve. Potential difference 1, how much is this? You can participate in the chat.
2.24.
2.24.
Yes.
Okay, 2.24 volts. Next one, delta V2, 1.12. Thank you. Next one is the same. Okay. The next one, the number 4.
2.8 volt.
2.8 volts. The next one.
1.68.
And with this, we're finished. That's it. We found the potential difference that is in each resistor is making up the circuit that we were working with. Now, how can we tell if this is correct? There is a procedure that we can use to check. Let's take a look. How can we check? Okay, you know that the total potential difference is how much? How much is the total potential difference in the circuit?
9 volts.
9 volts. How do you see it? Here in the equivalent circuit, the total is represented here, okay? 9 volts. So you say potential difference total is equal to, and then you add all the individual potential differences that we obtained in each resistor. Okay, so you're going to add 224 plus 112 plus 112 plus 28 plus 1.68. Okay, so how much is this? 8.96. Okay, 8.96 volt is not exact same as 9, but we can say that is approximately equal to 9 volts. That is what we are, that is the value that we are comparing to. So this is going to help us to see if what we got makes sense, okay? If it's close enough, you can say that what you did is right. This is the way that you can do, the way you can follow to see if the procedure that you did was okay. As you can see, it is a very simple procedure. Now, how can we open a parallel circuit? And this is what I wanted to tell you about. This is an exercise pretty much similar to the one that we did. As you can see, are the same resistor and the same battery, but the connection is in parallel. So, good question, by the way. In the part when we say that we need to open the circuit, if you open it, it's gonna be very weird, okay? It's gonna be like this. Then you're gonna have the first resistor in parallel, then the other two, the three, the four. So all these boxes that you see here tells you that the circuit is in parallel. But here, no need to do because we don't solve anything by opening. Okay? So in parallel circuits, you don't need to open. You don't need to open it because when you open it, yes, you can see that they are in parallel, but you can also see that they are in parallel here in the sketch. So how can you really tell if the circuit is in parallel? Take a look. The current travels in the wire, okay? So the current comes from here, and what happens in this point? In this point, what you notice, wait, what you notice is that the current now has two passes. So what is going to happen is that this current is going to divide here in one current and another current. So this part that you see right here is what determines it is a parallel circuit. It is different from the other. Remember that I showed you, okay? Here the current travels in one single path until the very end. But here, the current divides. So when the current divides, this tells you that you have a parallel resistor. And the parallel resistor will define the formula to use. Okay? So let's see. So here, as I told you, we don't need to open the circuit, so you go directly to the step number 2, which is to calculate the equivalent resistance. Because it is in parallel, the formula is different. You say 1 over rec equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Okay, this is the equation that you're going to use, and then just substitute by the givens. 1 over reg equals to 1 over 4 ohms plus 1 over 2 ohms plus 1 over 2 ohms plus 1 over 5 ohms plus 1 over 3 ohms. Okay, so in your calculator, you need to add the fractions. So how much is 1 over reg? Tell me the fraction, please.
107/60.
107 over 60. These are ohms. But because here reg is in the bottom, what I need to do is I need to apply the reciprocal function. Okay, so in the end, reg is going to be equal to, and what you do is you rotate the fraction. 60 goes up and 107 goes down, and then you just divide 60 by 107, and this gives you the equivalent resistance. How much is this? How much is this?
0.56.
0.56. And this is a resistor, so it is in ohms. Okay, important. Reg 0.56 ohm. It is different than in the exercise here. We got the current was 0.56. Take a look. It is different. Now, what we need to do after is we need to do the first part check. Reg is done, and now I need to work with the equivalent circuit. I just need to draw. Now the equivalent circuit, it is a very simple sketch. So it is just the battery, the equivalent resistor. The battery is 9 volts, and the equivalent resistor is 0.56 ohms. It is different than the one that we did. And if you want, you can put here the current to indicate that it works in this way, it behaves in this way. Now that you have the equivalent circuit, you need to get the current in the circuit by using Ohm's law. So I'm going to work in this part, okay? By Ohm's law, I'm going to find the current in the circuit. So step number 4, the current in the circuit. Okay? Applying Ohm's law, you have current equals potential difference divided by reg. So this you plug in the givens and you say, okay, current equals to 9 volts divided by 0.56 ohms. How much is this? How much is this?
16.07.
16.07. Here we're talking about current, so it's going to be amperes. Now, this current, I will put it here in the equivalent circuit. Instead of I put 16.07 amperes. Okay? Now, I need to go to the last part that says the current in each resistor by using Ohm's law. So I'm going to use the same law to find the current, but in each resistor. That means that I need to calculate the current 1 by using the resistor 1, okay? The current 2 by using the resistor 2, the current 3 by using the resistor 3, the current 4 by using the resistor 4, and the current 5 by using the resistor 5. I plug in the givens and I say current 1 equals to 9 volts divided by the first resistor. Here are the resistances. 42253. Okay, so this is 4 ohms, and current 2 is going to be 9 volts divided by the second resistor, that is 2 ohms. The current 3 is going to be 9 volts divided by the third resistor, that is 2 ohms. The fourth resistor is 9 volts divided by the fourth resistor, that is 5 ohms. And the last one is going to be current 5 equals to 9 volts, but now divided by 3 ohms. So the first current is how much?
2.25.
2.25 amperes. The second current is 9 divided by 2, 4.5 amperes. The third one is 9 divided by 2, again, 4.5 amperes. The other one, current 4, 9 divided by 5, how much is this?
1.8.
1.8.
1.8 amperes. And the current 5, 3 divided by 3, and 9 divided by 3 is
3.
3 amperes. So these are our partial answers. And again, we can check. How do you think we can check these answers? How can we do the check?
By adding all.
By adding all, exactly. So the total current, or the total current in the circuit, is going to be equal to the addition of each. So 2.25 amperes plus 4.5 amperes plus 4.5 amperes plus 1.8 amperes plus 3 amperes. How much is this?
16.05.
16.05. And the parameter by which we need to compare is the total current, which is 16.07 amperes. So we say that is okay. And voila.